In this part of episode 16, we're going to be talking about how to multiply together two polynomials. So, what is a polynomial? A polynomial is an expression that consists of many terms added together. By this, I mean that the quantity 2 times x cubed would be one term. The quantity 4 times x would be another term. The quantity 5 times x squared would be another term. An example of a polynomial would be what you get by adding and subtracting a bunch of different terms here. Polynomial means many terms. Now, if any of the terms in this list were like terms, then we could combine them. But none of the terms in this list are like because each of the terms has a different number of x's. So this expression cannot be simplified any further. This would be a fully simplified example of a polynomial, multiple terms added or subtracted with one another. Now, if you have two polynomials and you need to multiply them together, the process of multiplying together two polynomials is what's called distribution. Distribution is our name for how we multiply two polynomials together. And to give you an example of what this process looks like, suppose that someone asked me to multiply together the polynomial x plus 2 with the polynomial x plus 3. What process would I use? What would the process of distribution use to multiply this polynomial with this other one? Now, step number one is to multiply together every term in the first polynomial with every term in the second polynomial. There are a couple of different ways that we tend to represent this process. One way that I see students represent this process is to draw lines out from the terms of the first polynomial to the terms of the second polynomial. So the first term, x, in the first polynomial will need to touch and interact with both of the two terms in the second polynomial, and the 2 in the first polynomial will also have to interact with the two terms in the second polynomial. So x will have to get multiplied by x, and that'll give me x squared. X will have to get multiplied by 3, and that'll give me 3 times x. X will have to get multiplied by 2, and that'll give me 2 times x. 2 will also have to get multiplied by 3, and that'll give me 2 times 3, result 6. Another way that I will see students represent this product is to use kind of a grid that has the two terms of the first polynomial, 2 and then x and then plus 2, and then x and then plus 3. And then to fill in all the blanks in the grid with the products, x times 2 becomes 2x, x times 3 becomes 3x, and 2 times 3 becomes 6. Now, after you've multiplied every term in the first polynomial by every term in the second polynomial, step number 2 is to add all of these results together. So I would have x squared plus 3x plus 2x plus 6. And once that's done, I would check to see if I could simplify this answer at all by combining potentially any like terms that have appeared. So if I look in this expression, do I find any like terms in this expression? Well, 3x and 2x are like terms. The only difference between them is the coefficient in front. And so if I add together these like terms, if I combine these like terms, then in total I will have a pile of 5x's added together. So simplified, I would get x squared plus 5x plus 6 as the result of x plus 2 times x plus 3. This would be the result of this product, multiply x plus 2 by x plus 3. Now for a visual representation of what is going on when we do this process, if I think about, for example, a rectangle where the length of one of the sides of the rectangle is x plus 2, and the length of the other side of the rectangle is x plus 3, then the product x plus 2, x plus 3 would be the same thing as length times width, which would be the same thing as the area of this entire rectangle. But suppose that I split that rectangle into smaller pieces. Suppose that I split the rectangle and split this first side. So instead of it being x plus 2 all together, I split the side so that this portion was just the x part of it, and this portion was just the 2 part of it. And the other side I will split so instead of being x plus 3 all together, the first part of it is just x, and the second part of it is just the 3. If I split up the rectangle in this way, and I looked at the areas of each of the smaller rectangles that I formed, then the x times x give me length times width and would give me the area of this little piece in the upper left. 2 times x would give me the length times width, which is the area of this little piece in the upper right. 3 times x would be length times width, which would be the area of this little piece in the bottom left. And 2 times 3 would be 6, would be the area of this little piece in the bottom right. So by adding together the areas of each of these 4 pieces, I should get a result that's the same as the area of the whole rectangle if I calculated length times width by doing the length of this big side times the width of this big side. Let's do another example of the process of distribution. Someone says multiply together x minus 4 times x minus 1. So the first thing that I'm going to do is I'm going to multiply every single term in the first expression by every single term in the second expression. So x times x becomes x squared. And then the next product I take is of this x and then of this subtracted negative 1. And so if I do x times negative 1, if I multiply x by 1, it's just the same as it was before, still just x. And then applying a minus 1 will make it the opposite, negative x. Then I have negative 4 times x. This negative 4 in the first expression times x. And then I have the 2 in the back, negative 4 times negative 1. And this is an even number of minus signs, so the result will be positive, positive 4 in this case. If I wanted to express this as a grid instead of in this layout, I could also think of this as x negative 4, x negative 1. And if I fill in this grid with the products, x times x would be x squared, x times negative 4 would be negative 4x, x times minus 1 would be negative 1x, and then negative 4 times minus 1 would be 4. So just two different layouts of the same idea. So now that I have written down the four products that I get by multiplying every term in the first polynomial by every term in the second polynomial, all I have to do is combine these and add these together. So x squared plus negative minus x plus negative, so minus 4x, and then 4. And now do you see any like terms that we could combine? I think here we can combine this one negative x with these negative 4x's. If I combine those like terms, then I get a total of negative 5x's. So the result of multiplying together x minus 4 and x minus 1 is x squared minus 5x plus 4. Let's do another example. Someone says 2x cubed, the quantity 4x squared minus 1. So in this case, I have one term in the first polynomial, and I want to multiply that by each of the two terms in the second polynomial. So if I thought about the grid here, if I take 4 times 2, the product of these two coefficients, this will be 8. And then if I took x squared times x cubed, that would give me a total of 5 x's multiplied together, x to the 5th power. You can also get this by using the exponent properties from part 1 of this episode. And then if you multiply a quantity by negative 1, it just becomes the opposite, negative 2x cubed. Now that I've written down these two products, all I have to do is combine them, add them together, and I get 8x to the 5th power plus negative, so minus 2x cubed. These are not like terms because they have a different number of x's in each term, so they cannot be combined into a single term. And for a more complicated example, if I had two polynomials and each of the polynomials had 3 terms, I could, for example, use a 3 by 3 grid to organize my multiplication. One polynomial has x cubed, 2x, and 3. The other polynomial has x to the 4th power, negative 4x squared, and x. So if I took these products one at a time, x to the 4th power times x to the 3rd power, 4 multiplied x's multiplied by 3 multiplied x's gives me a total of 7 multiplied x's, x to the 7th power. 2 times x times another 4 multiplied x's gives me 2 and a total of 5 multiplied x's. 3 times x to the 4th power is just 3 times x to the 4th power. Then for the second row of the grid, x cubed times negative 4x squared has in total 5 multiplied x's. Negative 4 times 2 gives me a coefficient of negative 8. And then these two multiplied x's combined with one more multiplied x gives me in total 3 multiplied x's. Negative 4x squared times 3, I just multiply those two coefficients together. And this completes the next row. And then for the last row, 3 multiplied x's combined with 1 multiplied x gives me a total of 4 multiplied x's. 2 times x times another x is in total 2 and 2 multiplied x's. And then 3 times x is just 3 times x. So now all I have to do is add together all 9 of these terms. And see if there are any like terms in this list that can be combined. And again, for like terms, we're looking for terms that have the variables and exponents exactly the same, terms that are only different in the coefficient. So I think that 2x to the fifth power and negative 4x to the fifth power are like terms. I also see a 3x to the fourth power and a x to the fourth power. And I also see a negative 8x cubed with a positive, nah. I see a negative 12x squared with a positive 2x squared. So if I combine those like terms, the x to the fifth terms together become negative 2x to the fifth power. The x to the fourth power terms together become positive 4x to the fourth power. The x squared terms become negative 10 from negative 12 plus 2. And then the negative 8x to the third power was not able to be combined with anything, and the 3x was not able to be combined with anything. One final simple example, just multiplying a polynomial by negative 1. If I multiply a polynomial by negative 1, then I just have to make sure that that one term in the first polynomial gets multiplied by all 3 of the terms in the second polynomial. So negative 1 multiplied by x cubed just turns that into the opposite. Negative 1 times negative 5x just turns that into the opposite. And negative 1 times positive 1 will just turn that into the opposite. So multiplying by negative 1 just turns the whole polynomial into its opposite and changes the sign of each of the terms one by one.